Okay, so in this video we're going to look at one of the four basic transformations that we call translation. So we're going to look at translation, and to start with, what we need to do to perform any transformation is we need to draw a pair of axes. So we need to draw XY axes. So I'm going to keep this fairly simple. Let's start here and across like this. And when we're numbering up our axes, it's a good idea if we keep our numbering relatively small so it doesn't get in the way. And we can draw arrows both ends if we like, but if I just draw the arrow showing what the positive direction is, then we're now going into the negative. Okay. Okay, so that's drawn up our axes. Now we can start thinking about translation. All right. So we're going to translate by a vector. So if we translate by a vector, all that means is we're going to move the coordinate plane either in the, we might move it horizontally, we might move it vertically. Let's just start with a basic translation. Let's just move it horizontally. So we're going to move it by some number a, which could be positive or negative, so left or right, but we're not going to move it up or down, let's say. So we'll just set that at 0. So that's our vector, our translation vector. And perhaps the easiest way to look at this is if I start with a point here at 3, 2. Okay? So the coordinates of our point, let's call it A, are 3, 2. So translating A, 3, 2 by, let's say, by 3 units. Okay, now what we're actually doing is moving everything on the coordinate plane when we do any transformation. So I'm going to show that by literally shifting the grid 3 squares to the right. Now let's keep our eye on this point to see where it will end up. So the translation moves point A to, let's call it A prime. So A prime, so it gives us A prime at 6, 2. Okay? So if the vector was 3, 0, all I had to do was add that 3 to the x coordinate, to 3 here, to get 6, and then I've got my resultant vector. Okay, I've got my coordinate. I've got my image of A, we should say. So if this is the object, we call this the image. Okay, let's do another one. Let's in fact move the same vector, the same point in now the vertical direction. So we're going to try and move it up. So if we translate now by, we're going to fix the first component of the vector, but give some number b for the second component. So that will move it up or down. And let's move it up by 2. So let b equal 2. Okay, so again, if we just move the coordinate plane, we can see that everything will then translate. So even A prime would translate up, but we'll leave it where it is. So move this up, and we can see now that this point here, we'll call it A prime prime, is going to be, so it's going to be at, let's put it here, A prime prime is going to be at, okay, it's going to be at 3, 4. At 3, 4. And let's check. Well, we set B at 2, so we had a translation vector of 0, 2. So it's going to take A and do nothing to the x-coordinate, so 3 remains the same, but 2, it's going to add 2 to it, so 2 add 2, 4 gives us A prime. Okay, finally, let's combine our two vectors, so now we're going to translate by, well, let's just add them together. So A plus 0 is A, and 0 plus B is B. So that will give us a translation vector of, say, 3, 2. So where's that going to go? Again, let's move the coordinate plane along 3, up 2, and that will take it along the vector here. So let's see if we can trace that to there. So let's call this A prime prime prime. Okay, so it gives us A prime prime at coordinates what? 4, 6. So we got 6, 4. Okay, does that make sense? Well, our original vector was A, so the object is A. The x-coordinate is 3, we added 3 to it, we got 6. The y-coordinate was 2, we added 2 to it, and we got 4. So even without the diagram, we should be able to do translation simply by taking the vector and adding it to the coordinates. Adding each of the components of the vector to the coordinates will give us our image. Okay? Alright, so that's an introduction to vectors. What usually happens in a question, so we go for an example here, is rather than a point or even a line, very often we're asked to translate a whole shape. So everything in the shape will translate by a vector. Let's, for example, use the vector 3, 2 and draw just a little square. So we'll just draw out a square here, and let's label our square A, B, C, D. Okay, so if we look at the coordinates here, let's start with A. A is at minus 2, 1. What's B? B is at minus 2, 0. C is at minus 1, 0. Minus 1, 0. And D is at minus 1, 1. So we should be able to predict where our translated shape, A prime, B prime, C prime, D prime, is going to end up simply by using the translation vector, so 3, 2. Let's have a go. So A prime should end up at, well, minus 2 plus 3, so that's going to be 1. 1 plus 2 gives us 3. So A prime should be at 1, 3. B prime, minus 2 plus 3 is going to be 1. 0 plus 2 is 2. C prime, minus 1 plus 3, 2. 0 plus 2, 2. And D prime, minus 1 plus 3, 2. 2 plus 1, 2 plus 1, 2. So those are our coordinates that we're expecting. Is that right? 1%? Yeah, it should be. Let's have a look and see if we're correct. And if not, let's go and see where things might have gone wrong. Okay. So the easiest way to do this, if you do have a diagram, really is to just draw a vector. So what I'm going to do is change pen color and just draw my 3, 2 vector and see where A ends up. So 1, 2, 3, 1, 2 should end up there. Okay. Now let's check against what we thought A prime was going to be. Well, that was correct. So 1 along and 3 up. First one is correct. Let's have a look at, let's do C prime in fact, because that's going to be easier to draw. So C prime, again, draw our vector. So it's going to be 3 along, 2 up to here. Okay. So this should be C prime. And C prime is 2, 2. So C prime is 2, 2. So that's also correct. All right. Now, from here, we can actually draw our square in. We don't need to draw the other vectors, I don't think. So let's just draw in the square. Okay. And if I label B prime and D prime, let's check that the coordinates that we've got for B prime are what we were expecting. So B prime is 1, 2. 1, 2, so that is correct. And finally, let's check D prime. So D prime is at 2, 3. So 2, no, there's a mistake here. So let's go back to D. We've got -1 plus 3 giving us 2. 1 plus 2 should have been 3. Okay. So should have been 3. And now we've got the right answer. Okay. So in other words, what we've got is a graphic method and also a more algebraic method, 2 methods to get the result, so we can use one to check the other. Okay, let's finally, on this part, let's try a different shape. And this time what I'm going to do is I'm going to draw the shape, draw both shapes, and see if we can work out what the translation vector is going to be. So if we call this problem A, problem B is going to work, so call this problem A. Problem B is going to be working the other way around. We're going to take a shape, let's draw it, let's draw it here. Oops, there we go. Now down to here. So let's draw a triangle, and we're going to translate that triangle down to here. So let's draw another triangle down to, let's see, down to here. Okay, so there we've got a congruent shape, and labeling up the vertices is always a good idea. So we've got A, B, C, and we're translating that to A prime, B prime, C prime. Okay, so problem B is going to be what is the translation. So let's start with our coordinates. We've got A now at 1, 2. We've got B is at 5, so let's draw that a bit neater so I can read it better. 5, 3, so 5, 3. And C is at 3, 4. So we should expect A prime to be at, well, let's check what A prime is. We're given A prime. So A prime is at -4, -1. And in fact, we can stop there, because if we've got 2 coordinates, we should be able to work out what the translation vector is. In other words, what do I need to add to that 1 to get to -4? So let's just work to one side, algebraically, what do I need to add to 1? So 1 plus a should give me minus 4. Okay, so if we algebraically rearrange this, so take 1 from both sides, we'll have a equals minus 4 minus 1. Minus 4 minus 1 is minus 5. So expecting a to be minus 5. What about b? Well, again, what do we need to add to 2 to give us minus 1? So 2 plus b, that we don't know, should give us minus 1. So b must equal minus 1, so subtract 2 from both sides, minus 1 minus 2, so b equals minus 3. So now we've got our vector that we're expecting of minus 5, minus 3. Let's use a graphic method now to confirm that result. Okay, so let's join a to a prime. So a to a prime we can write like that. So a to a prime is what? Well, let's draw it in. Okay, so a to a prime. If I draw the arrowhead here straight away and then just draw down, and then I just need to count the squares. 1, 2, 3, 4, 5 so to the left, so in the negative direction, and 1, 2, 3, 3 again downward, so away from this arrow, so in the negative direction, so it is minus 5, minus 3. So whoops, minus 5 for the first component and minus 3 in the second component. So that confirms what we had before, but what I'm going to do is now a check. Just in case we've made a mistake, let's just check one of the other vectors. So let's check, let's say c to c prime. So again, let's draw the vector. Needs to be in this direction, so c to c prime, so there's the arrowhead. So counting 1, 2, 3, 4, 5 in the negative direction, 1, 2, 3 again in the negative direction, so we've got minus 5, minus 3. So we can say that this result, this is the vector that we must have been using. Okay, now we've looked at translating points, lines and shapes. What about translating a function? So a function is when we have something like y equals x squared. The function bit is the x squared. In other words, we're saying, what do we do to any number x? We square it. That's what the function is. And it produces what we call the dependent variable, the y value. So let's write that down. The function of x, so we can write that f of x equals x squared. And we can draw it on our graph. So we've got a graphic representation of the x squared function. Alright, and I'm sure you're fairly familiar with this. We simply take every number, so we can draw a t-table, or we can just draw it directly onto here. So 0 squared would be 0, 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, and so on, until we end up with a curve, which I'm just going to very quickly draw on here, like this. And let's use a red pen. And let's use amber, there we go. Okay, so there we go. So f of x is x squared. Well, look, on a graph like this, we'll draw a line like this. What if I wanted to translate this function, let's say up or down? Okay. Well, if I translate something up or down, what kind of transformation am I going to be using? I'm going to be transforming by a vector. I'm going to be translating by a vector with no right or left direction. So my first component is going to be 0. Up and down means I'm only going to be using the second component. Well, let's draw a translated curve. So let's move it down. So in other words, I'm going to be translating it down, let's say right to the bottom here. Okay, so that's going to look something like this. And in fact, we can say that this represents the curve that I've just drawn. Represents, so f of x, let's call it g of x in fact. So our new function isn't just x squared, it's x squared, but every number has been brought down by 8. So it's going to be x squared minus 8. And I'm just going to write minus 8 in a slightly different colour, because minus 8 has got to be then the vector that this has been translated by. Okay, so in other words, the translation can be expressed as curve has been translated by 0 in the left-right direction, but minus 8. And so if we were going to express this algebraically, we would just say not minus b, we would just say b. So 0b, translated by 0b. So the general term would be 0b. Okay, so you just take this number here and put it as the second component of the vector, and then you'll get the translation up or down. Very straightforward then. Okay, what about, let's call it h of x. What about if I drew my curve over to the left? Well, if I draw my curve over to the left and still want it to be the same shape, then however far over to the left, let's say to 5 here, so I'm going to have to bring it back in a way to get the same values. So I'm going to have to add 5. So h of x must be x plus 5 to compensate for that direction that I pulled it in the negative direction, so I've got to pull it back. So it's now not x, but x plus 5 squared. Okay? And again, the change here, the alteration of the basic function has been, is this number in the brackets here. So what I'm going to do is just mark that out again by a slightly different, with a slightly different colour. So that's plus 5. Now let's think about that. Well, in fact, let's draw it. Let's just draw that on the graph to start with. So that will look something like this. Erase that, and then that should now draw, there we go, a nice curve there. Okay, so let's think about what's happened here very carefully, because what we've got is a translation to the left, and yet our number in brackets here is positive, and normally translation to the left is positive. So how have we translated our shape? In this case, a curve, our curve or function. Well, we must have translated it 0 up and down, but not 5, not positive 5, but negative 5. So negative 5. In other words, what we've had to do is change the sign. To move it to the left, we've actually had to put plus 5 into our function. So the general, let's do this in green maybe. So the general expression will be like this. 0 up or down, so the second component is 0, but this number has to be negative, so minus a. Okay, now the reason I've gone through this so carefully is because I want to think about now, let's bring this red curve back, I want to think about any translation, any shift that I want to make of any function being a combination of these two vectors. So the resultant vector is going to allow me to move it anywhere. For example, I might want to move this down and to the left, so move it to down here. That would give me something like this. Okay, so I've moved it down and to the left, which is going to be achieved by a combination of these two translations. So let's write that down. So a combined translation is going to be the resultant vector in this case 0 plus minus 5, so 0 minus 5, in other words minus 5. That moves it to the left. And minus 8 plus 0, in other words minus 8, and that moves it down. My general expression, let's use blue pen, my general expression then is going to be a combination of these two. So I've got 0 plus minus a, it's going to be minus a, so whatever number I'm going to translate it by, it has to be negative, and then b plus 0, b. So my general expression for the vector is minus a, b. Now what does that mean in terms of the function? It gives me a nice easy way now to describe our final function here. Let's call it I of x. So the blue one is I of x. I of x then must be what? Well, first of all, I've got to look at what goes in the brackets. X, what's happened to x? X has to be minus a. So if a was minus 5, then I have to change the sign. So the minus a tells me to change the sign. So therefore it's got to be plus 5. Okay? And this gets squared, and the second number, the constant that's out front that takes it up or down, is going to be just this number b. So in this case it's minus 8. So minus 8. So by using this idea of a combined transformation, this translation function, what I've been able to do is find an expression for I of x. And if I wanted, I could now write this as y equals x plus 5 squared. Well, that's going to be x squared plus 5x plus 5x, so 10x. 5 times 5, 25, minus 8, give me a final expression of y equals x squared plus 10x. 25 minus 8 is going to be plus 17. So the polynomial equation for this line must be y equals x squared plus 10x plus 17.